Hi, the topic of this video is construction of deterministic finite automata. So the question is construct a DFA for language L is equal to b raised to m a b raised to n where m and n is greater than equal to 0. So first of all I will write the possible string generated from this language and then we will construct the automata. So there are some examples. So for this m is equal to 1, n is equal to 1, it will be b a b. Then for m is equal to 2, n is equal to 2, it will be double A, double B A, double B. Then m is equal to 3, n is equal to 3, it will be triple A, triple B. For m is equal to 2, it will be double A, B. Then for m is equal to 4, n is equal to 2, it will be 4 times B, A, double B. And for m is equal to 4, n is equal to 3, it will be 4 times b, a, triple b. So these are some of the examples. So let us construct the automata. So we have to remember one thing: string should not start with a, string should not start with and end with a. So let us construct automata. First one is q0, then next state is q1. So for b. So for first string BAB, we can simply construct the automata B, then this is Q2, then this is Q3, B, A, B. So this is the automata. Then for if you take double B, A, double B, double B, A, double B. So if you apply the loop here, then we can solve the, it can solve the purpose, because there can be triple B, A, double B, then triple B, A, triple B. So triple B, 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 A, B. So here we have to apply the loop so that it can accept any number of B. So this is the possible automata which is accepting B, A, B. Okay. So now if we take double B, A, B, 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 A, B. 4 times B, A, double B, 4 times, 1, 2, 3, 4 times B, A, B, B. Now the string cannot start with A. If the string start with A, we use this to dead state, so it will be A. Okay. Now after, if you take here example, string should not end with A. String should not end with A. So if it ends with A, we can write down this thing. Okay. Then after A, there should not be A. After A, there should not be A because there is only single A. So we can write here A. And then if the, let us say the string is triple A only. So if we apply the loop here A of A, it can accept any number of A. Then B, A, B, double A. So suppose the string is B, A, B, double A. So what to do? B, A, B, A. So if double A loop is here, but string is suppose B, A, B, A, B. This is invalid string, double B, let us say. So B, A, B, A. So if we apply the loop of B, it will solve our purpose. So this is the final deterministic automata for the language B raised to m, A, B raised to n, where m and n is greater than 0. So I do you understand this automata?